So this video is going to be on limits graphically. So just a quick recall, remember that limits are equal to y values, or the y value being approached. All right, and this is when it's approaching a given x value, okay? So this first limit is going to be a left-sided limit. And we know it's left-sided because we see the limit as x approaches c from the negative side, or the left side, for f of x. So this is the y value approached when x approaches c from the left. And then this next one, we have a plus as a superscript. This is going to be a right-sided limit. All right, so we'll go ahead and copy the same. And if you ever need to catch up, just pause since I'm copying and pasting. But instead of using the word left, we will use the word right. And then this last one, this is when the left-sided limit agrees with the right-sided limit. That means the limit as x approaches that constant exists, okay? So it's going to be the same statement. Let's see if I can get it. Awesome. So the y value approached when x approaches c from both sides. And again, this only occurs when the left-sided limit and the right-sided limit are approaching the same value. So if you want to read this, you can go ahead and pause it. In previous videos, I was just reading aloud to you. But if you want to read through this, go ahead and pause it. However, I'm going to continue to the next one. So we have a function. We have f of x as the limit. F of x is equal to the limit as x approaches 4 for x squared minus 2x minus 8 over x minus 4. Now, we see a quadratic divided by a linear, but the visual shows us that it's a linear function. So for some of these limits, you're going to have to factor and simplify so that we can see where those removable discontinuities are. All right, so if we have x squared minus 2x minus 8 divided by x minus 4, we want two numbers that multiply to negative 8 but add up to negative 2. So we will have x minus 4 times x plus 2 divided by x minus 4. So from here, we can see that we have a factor in the numerator and the denominator that will cancel out. So we're left with x minus 2, which leaves a whole at x equals 4. All right, so if we take a look at these limits over here, the limit as x approaches 0 for this function. So for these limits, you want to zoom in as close as possible, all right, and see what's going on. However, the first thing that you can try is just substitution, all right? If there's no discontinuities or a corner, a cusp, or a vertical tangent line, any of those things that we talked about in the previous lesson, then the limit should exist. However, sometimes if you plug in 4 into this, you get 0 over 0, which that doesn't mean it doesn't exist, clearly, because we proved that over here. That just means you might have to use a different method depending on the type of discontinuity that we are running into, okay? So at 0, if we plug in 0 into our simplified form, which is x plus 2, we get 2. Now the limit as x approaches 2, plug it in. You get 2 plus 2, which is going to be 4. And then the limit as x approaches 4. Yes, there is a discontinuity there, but since we simplified our f of x, we are able to directly plug that in, and we get 6. Even though f of x is undefined at 6, limits do not care about what's happening at a point. They only care about what's happening as we approach a point. So it's not about where we are, it's about where we are going, okay? So this one will be 6. All right, the next one, it says sketch a graph of f of x, then evaluate the limits shown. Okay, so I have x plus 1 over x squared minus x minus 2. We're going to have to do some factoring first. So x plus 1 over x squared minus x minus 2. So we'll have x plus 1. We want to have two numbers that multiply to negative 2 but add up to negative 1. So we'll have x minus 2 times x plus 1. And the x plus 1s will cancel out. So we're going to have a whole at x equals 1. And then we'll have 1 over x minus 2. So a couple attributes we're going to see is that we have a whole at x equals 2. not 2. It's at -1. Okay, so x equals -1. And to get the output value, I feel like they're going to, they might ask what the output is, or the limit for the whole. So if I plug in -1 into the simplified form, I get -1/3. Now we also have to take into account that we have a vertical asymptote at x equals 2. And because it's a rational function, we also have a horizontal asymptote at y equals 0 because it is bottom heavy. Okay. So if we draw our quadrants, 1, 2, 3, 4, 5, 3, 1, 2, 3. All right, so I'll go ahead and include my 2 asymptotes, horizontal asymptote at 0, and then a vertical asymptote at 2. Now we also have that hole at -1, -1/3, so I'll include that, which puts our curve under the asymptote here. And then we have another curve that is above the asymptote here. All right, so now we can go ahead and start evaluating. So the limit as x approaches -1, awesome. That is the removable discontinuity, that is our hole. And we already solved for that output, which is going to be -1/3. The limit as x approaches 0, always try direct substitution first. If I directly substitute 0 into the simplified form or the original form, you are going to get -1/2. Part C, that should be +2. So as x approaches 2 from the left, now at 2, that's where the vertical asymptote occurs, okay? And if I approach that vertical asymptote from the left, I can see that our curve is decreasing infinitely, okay? So there are a couple solutions for this. This is going to be -infinity or does not exist. So either of those will satisfy this limit. Part D, that should also be +2. So as x approaches 2 from the right, but now we are going in the positive direction, so going to +infinity. So this one can either be +infinity or does not exist. Part E, that should be as x approaches 2. So if we look at 2, now we talked about this before. In order for this limit to exist, the y value approach when x approaches c from both sides, they have to agree. Both sided, what? C from both sides, I just noticed that. Sorry about that. So the left and right limit have to agree. So the left limit is going to -infinity, the right limit is going to +infinity. So the only answer that we can get for this one is does not exist. For part F, as x approaches 3, if you directly substitute 3 into the simplified form or the original form, you will end up with 1. All right, hope that was helpful. The next video will be on evaluating limits analytically.